There we go. So when we're looking at graphing this function, how do you start? Like, what are you looking at?
Break it up.
Brandon?
First place I started was with the change in amplitude.
So you're starting to look at one thing at a time.
Yeah,
So you're starting to look with the what number?
with the 4.
The 4. So you're looking at the change in amplitude. And Alyssa, you said break it apart. Okay. So for me, when I'm breaking these apart, the very first thing I'm going to do is I'm going to get a sketch of my parent function. Because you said the change in amplitude.
Mm-hmm.
Change from what?
From 1.
From 1. So you're kind of going back to the original. But you realize there's things being modified here. There's things being changed. So we really want to know what the basic one looks like in the first place. So I'm going to focus on cosine here. And I'm just going to create a quick sketch. What does cosine look like? Come on, sketch with your finger. It can't just be Brandon. Okay. Cool. So it looks something like that. Yeah, it doesn't end there. It keeps going forever. Nice job, Noah. And then I also want to know, if we're going to change this, I'd like to know, what do I know actually about this one? So what do we know about this graph, the parent function? Important characteristics. Give me one, Mitch.
Of that function?
Yep, of the blue one, the parent function.
The amplitude is equal to the radius?
But if we're just looking at the parent function, I don't necessarily like the amplitude's equal to the radius, but we're just looking at cosine.
Sort of be equal to the x then? No, it'd just be 1.
It'd just be 1. Okay, so we know the amplitude's 1, so I know that's 1, and I know this down here is -1. What's something else that we know that's important on this? Emily?
The period's 2 pi.
The period's 2 pi. So by the time I get through one complete cycle and started to repeat, we would know we'd be at 2 pi. And now we can start to talk about how we change this. So Brandon, you said what?
I said amplitude. Change the look at the amplitude.
What is the amplitude?
What is it changed to?
Yeah,
4.
and you're looking at this 4 here?
Correct.
Okay, so tell me something else you know.
Well, the next
No, not you. Tell me something else you know. Give me something else you know. 1, 2, 3, 4. Not good enough? Everybody up.
The graph is up 1.
How do you know the graph is shifted up 1? So you're looking at this and you're saying it's vertically shifted by +1. I love the fact that she went to the 1 and skipped over the middle piece. So when you look at it, Brandon talked about how much it's stretched out vertically. Brighton's talking about how much it's shifting vertically, which means we're kind of focusing on just what does it look like vertically. So if you think about this now, if we come over to the axes, yay for bells. If we come over to the axes, what can we label? What are some important points to label? Michaela?
Well, yeah, where on the y-axis that it starts. Or
What do you mean?
goes through the y-intercept.
Okay, so what is the y-intercept for this one?
It's
Okay, so you're having to do a little bit of thinking there. So maybe we can break it down even better. Just focus on one thing at a time. What's something I could label on the y-axis that's important? Thomas? 4? So is 4 going to be a critical number to label on the y-axis?
No.
Ah, so what if I just start to label that 1 vertically? What's the significance of 1? It adds to the 4. What's the other significance of 1? Glenis?
Is the y-intercept.
For this function?
Yeah.
Where does cosine start? Look at the Or think about the y-intercept of cosine.
Or
Yeah, it becomes a little different, right? What's the other significance of the 1? Bryce?
I don't know, going off of, if you want us to go on the path of y-intercept, I'd say if you do 1 plus 4, that's your y-intercept.
Okay, so we could get the y-intercept.
The coefficient of cosine plus the thing outside of the whole cosine function.
So this has a y-intercept of 5, and I 100% agree. To me, I see that 1, I wasn't necessarily pressing for the y-intercept. That's what everybody else decided to bring up. To me, the 1 is where that vertical center line is. If you think about normally, that vertical center line is really the x-axis. If we shift the graph up 1, that's where it is now. And Bryce got us our maximum. What's our minimum? Madeline? -3. All right. Oh, shoot. Labeled that in the wrong spot. There we go. Now it looks symmetrical. So we've now got some information on the y-axis. So dive back in. Tell me something else you know about the function. Tell me something else you know about the function.
Well, I mean, the one thing that I don't think one of us has touched on is the minus pi 2, right? Or
Correct.
Shifts the graph.
Yeah.
Shifts the graph which way?
y-axis.
So Bryce, you're saying it takes the y-axis and it shifts it which way? To the left?
This is where I kind of lost it. I don't really know.
Okay. Does somebody see it differently? Emily?
It moves the y-intercept of cosine to the right.
So it's kind of, if it moves the y-intercept, you're really kind of talking about it's moving the whole graph, right?
Yeah.
So you're saying we could look like it's shifting. The graph is either shifting rightward or the axis is shifting leftward. Yeah, Bryce?
Is that number the x-intercept or no?
It depends.
Well, yeah, because it goes back.
It depends. Depends on the function. So look at it. How many people like to see it as the axis shifted? How many people see it as the graph shifting? Okay, so we're 50-50 mix. Let's look at it as the axis shifting. So come up here to our parent function, right up here. And I want us to think about if we take the axis and we shift it back pi over 2,
It'll be
where is it going to be?
on the inclined slope.
What do you mean at 0?
Where it's gonna be where your graph intercepts your x-axis.
Yeah.
So it's going to be at that x-intercept that's right back there.
See what I'm saying? How ours is supposed to be.
What color do you got with that thing?
Tons. So when you look at this, that means that gray line is now the new y-axis. So we can see what the graph is going to look like. It's going to look like this. Which reminds us a lot of sine. It looks exactly like sine to me. So now at this point, I'm going to come over to my graph and I'm going to start to plot points. I'm still operating out of what do I know, what do I know, what do I know, what do I know. I'm breaking it down. I don't want to sketch the whole graph now because that's hard. I'm going to sketch one thing at a time. So I know if you look right here, that's where it crosses the y-axis. So I'm going to sketch that point. Notice it's right on that center line. So I'm going to sketch that point right on my vertical center line. Ooh, I forgot something.
Yeah, you didn't move the axis.
I did.
You did on that one.
What'd you forget?
So what do you want?
Nope, the y-axis used to be there, Alyssa. See that blue line?
Right, but what about on the big graph? You didn't have the big graph.
This is my work right here for seeing what it's going to look like. So this is where I'm seeing my axis shift.
What did you forget?
I have nothing labeled on the x-axis.
Sure don't.
What would I want to put on the x-axis? Why 2 pi? Not you, not you, not you. You've been very helpful, gentlemen.
Yeah, right.
Alice.
You want to put 2 pi because that's the length of 1 period.
Okay. So 2 pi is the length of 1 period for this one because it was unchanged. And so I'm going to put 2 pi. And more importantly for me, actually not more importantly, equally important, I want to know where the period is, but then I'm going to divide it up into those quarter sections. That's why I made the choice to go 4 sections out, four boxes out, because the circle is nicely divided into quarters. So I know the period is going to end here, which means if it starts at that vertical center line, it's also going to end. That's where a full cycle ends. And I'm going to keep just plotting points that I know. I'm going to come over to here to the shape. The first quarter. See how it gets to a max? So after the first quarter, I'm going to be up at my maximum. And then the next quarter, I come over here. And I'm going to be up at that kind of 0 line. It's my center line, right? And then I'm going to go another quarter. I'm going to be down at my minimum. Maybe I can make a point. Darn, there it is. And then I already know where I'm going to go from there. And now I just get to play connect the dots. Using what I know about shape, at least as much as possible. Maybe I should have spread it out a little bit more, right?
Man, the
That's
center
nice.
place. Ugh.
Beautiful.
Should I listen?
I think it's pretty decent.
Could be worse.
Bunch of hooligans. And then if I wanted to see what it keeps looking like, I can just sketch from there.
Wow.
Hey,
You
hey.
stopped while you were at
Really?
I think it's pretty good.
It's like they get rid of the mountain from the
It's
heart.
kind of
It's kind of sketchy, I agree. Ha ha, funny.
Alice said that, not me. I'm not taking credit for that.
Yes, Emily.
So how do you know exactly where the pi over 2 is on the graph?
Are you talking about over here in yellow?
When you,
When I shifted the axis?
yes, like how do you know exactly like how far to shift it?
Well, for me, we know we're looking for negative pi. If I want to shift it, if I want to shift the axis negative pi over 2, I really want to see on this graph, the one circled in yellow, where would negative pi over 2 be? You follow me so far?
Yeah.
So I'm kind of thinking about on the circle, this is going to get really sloppy unless I erase some stuff. I'm kind of thinking about on the circle, where is that negative pi over 2?
-3.
Right. And so if you think about it, that's really kind of a quarter of a cycle. And so I wanted to go a quarter of a cycle backward.
Okay, so kind of think of it on the circle when you're shifting here.
Yeah, a lot of times I'm thinking about like how much of the period is this?
Okay.
It's a quarter cycle.